Have you ever given someone direction on a project, and when you come back to see the end result, you found out that they didn't do anything that you expected? But when you watch them do it, the outcome is what you were hoping for. Happens all the time with people, right? But what if I told you that light is the same way and behaves differently depending on whether it is being observed? This is the heart of the double slit experiment. Scientists projected a beam of light through two narrow slits that were cut through a panel and cast onto a screen. The expectation was that the light would shine through the slits and project two beams of light onto the wall. But when they looked at the results, instead of getting two evenly distributed bars of light as hypothesized, the back wall instead showed a repeating, alternating pattern of light bars. This was completely unexpected. After further consideration, this was assumed it was because when the light was not being observed, it took on the property of light waves. And if you think about waves on a pond, the ripples tend to merge together as they travel further from the source. Likewise, the light waves interfered with themselves. Areas on the wall where the waves canceled didn't have light, and areas without interference came through more brightly. The exercise was even repeated by sending one particle at a time, and the results were the same, indicating that the photons only had themselves to interfere with. Scientists tried this experiment again, but this time used a photon detector to measure the light particles as they went through each slit, carefully observing which slit the light photons traveled through. But surprisingly, the interference pattern disappeared, and the photons started behaving like particles. So instead of an alternating pattern of light and dark bands, scientists observed two bright, evenly distributed bands, indicating that the photons had to choose which slit to pass through. The conclusion was that light can display characteristics of both waves and as particles, and it appears that the light chooses how to behave based on whether or not it's being observed. When observed, the photons are interrupted by the observer, but when left to their own devices, the light waves are only interrupted by themselves. Now, scientists have tried for decades to come up with rules and an understanding of the quantum mechanics behind this. Even Einstein struggled and failed to make this phenomenon make sense. As leaders, do we do this with our teams? Do we sometimes micromanage or observe their every move, only to yield results exactly as we expected? Or do we allow others to be free, to be only interrupted by themselves, with results that wind up completely unexpected and sometimes better or more beautiful than we could have imagined? Sure, there's a time and place for receiving structured and predictable results, but we also have to allow ourselves and our teams the freedom and flexibility to think outside of the confines of the planned experiment, to not watch or observe or measure every movement, and instead allow them to generate results that are completely unexpected. The final outcome may just surprise you.